So, hello everyone, good morning. Thanks to the organizers for having us, and it's good to be back. I think I was at this conference 3 years ago, the last time we were in person. It's nice to see your faces again. So I'm going to talk about Ibis really quick, just a little about me. My name is Gil Forsyth. I work at Voltron Data. On the left are the places you can find me on the internet. And on the right are some things I've done, which I've just included here to say that if you're thinking about making a change and you aren't sure if you can, you definitely can. So Ibis is a lightweight Python library for data wrangling. And it was built by all of these lovely people and some more. But before I talk about Ibis, I just want to get a quick show of hands. Has anybody ever had to translate data analysis from Pandas to PySpark? Yeah, or like prototype something in Pandas and thrown it over a wall to a data engineer so they could re-implement it. Or maybe you were the data engineer and something was thrown at you, or you used Parquet as a cross-language serialization format. So like Pandas and PySpark here are just representative. You can fill in the tools on the left and the right there for any number of things. And none of these tools are bad, quite the opposite, right? It's just that, well, and none of these things even are bad, except like throwing stuff over a wall. That's bad. But what it is representative of is that in the PyData stack, there are two assumptions, which is that the first assumption is that your data is local and that your data fits in memory. And that is a pretty common assumption made by almost all of these tools. And so what does that look like? Well, it might look something like this. If you have your local laptop and some kind of remote engine, and you're going to connect to that engine, and you're going to say, hey, do you have some table called ratings, maybe? And then you're going to slurp up that entire table, and then you're going to load it and parse the types and perform your analysis, right? So there are potentially some issues with this, and this may be totally fine also. But potentially, one, if you're out of memory, you are out of luck, right? And this doesn't scale particularly well. And again, Pandas and Postgres here are representative. I mean, Pandas is the 800-pound gorilla in the room. So this pattern also treats the remote engine like it's a data store. And it is, but that's not all that those engines can do. And this is a pattern that shows up over and over again in the PyData stack, especially in relation to, for lack of a better word, the enterprise. And so what I call this is the PyData translation problem, which is in practice, the tool chain that's available for local development on like an enterprise laptop is different from what the eventual production job is going to run against. Now these two boxes here are far from exhaustive, and yes, like some tools in there can move into one or the other one. But by and large, there is a gap, and we want to bridge that gap. And one of the tools that nominally promises to remove this hurdle is SQL. So we need to talk about SQL. You know, the structured query language, it's been around for a long time. You've probably written at least a little bit of it. But most importantly, it is absolutely everywhere. And it is between you and the data. And however, it's not without its problems, right? So some pros and cons. Always a good sign when all the pros have caveats and, you know. So SQL is standardized, kind of, not really. We'll talk more about that. And it's concise. The cons, it's effectively untestable. That conciseness sometimes means that it's inscrutable. And it fails at runtime. But does it solve the translation problem? No, it doesn't. So the claim is just write SQL. You can always execute SQL, and there's no divide between dev and prod. So let's say in that instance, you have your local machine. Let's say you do it in your text editor or some CLI tool, but you somehow conjure a query. And then you connect to the engine, you send the query, it executes the query, and you get the results back. This is fine, but a couple of things. One, this is not a very tight loop when you're doing exploratory work. And secondly, you may not be allowed to run queries against prod when you're doing exploratory data analysis. There can often be restrictions on when you're allowed to connect, what you're allowed to run. So maybe instead, you get like a local sample, right? You could do this with like SQLite or duckdb or something. And now you've got this tight loop on your laptop, and you can kind of iterate there on a sample of the data. Now you're not conjuring a query, you've actually run it, like great. So now you have a kind of a little more confidence that it's going to run. Then you send it over to the big engine. You send it over, it executes, it returns the results, right? Problem solved. There are a few issues here, right? So let's look at a different translation problem, right? So let's say we have a simple data cleaning task, right? So we've got the table on the left, the table on the right. And the left is what's in the data store, and it's been ingested incorrectly, right? So you've got some tconst, some standard key. You have an average rating, you have the number of votes. And it's just all been ingested as strings. And like, sure, you could petition to have this changed and fixed upstream, but realistically, that's not gonna happen. And so what you wanna do is just do some casting, right? The average rating should be a float, and the number of votes should be an integer. So that's a pretty straightforward task to do, right? A couple of lines. So if you write this in SQLite, you get the above. If you write it in Postgres, you get the below, right? This is a very simple task, and already things have diverged, right? Now this is not an insurmountable divide, and what I'm talking about is, the data types have different names even though they're referring to the same thing. It's not insurmountable, we'll come back to it, but the general takeaway here is that you definitely want to avoid maintaining two versions of nearly the same script if possible. Like, someone's gonna change one of them and not the other one, something's gonna go wrong, it's gonna go badly. SQL also has what I call a parameterization problem, which is like, are you running one big query or are you running like many smaller queries, right? And like, how are you running those 1,000 queries? How are you generating them? Like, you wanna grab the top 10 movies, but also, let's say, ones that have certain keywords in them, and maybe that's on the basis of which user you have. So you have to generate all that SQL. Are you saving them out as like individual SQL queries? How are you batching over the execution? What happens when someone's keywords are like none and null? You're gonna find that out when it fails at runtime. There's another issue, which is that I want to write my stuff in Python. I like Python and I want to use it. And there's the final issue, which is that I don't want to write SQL. Like, SQL can be very concise. Some operations are really hard to spell. And you can definitely do anything in SQL, but do you want to learn about recursive common table expressions? I guarantee the answer is no. You really don't. So what is a solution to this problem? Presented with translation problem, parameterization problem. We want to use Python. We don't want to write a bunch of SQL. Some people will say, I know, I'll generate strings. We've all done this. We can forgive ourselves. So let's recall this simple example. We're gonna string SQLify this, right? So all we need to do, pick up a couple of format fields. Maybe we write like a small little mapping or a little helper function, look at what engine we're using. When I say float, what I mean is real, or I mean, whatever, double precision or what have you. And so this is fine. This is very straightforward. It's okay. But remember, you've got the translation problem, which is that, first off, the function names, when you're two engines, may be different. They probably are. Or the function exists in one engine and not in the other one. Like, maybe you have a mode function and your other engine doesn't have a mode function. Function argument order can differ. So like, you take the log of x to some base b. Does x come first in the arguments or does b first? There's no like right answer to that question. So like, who knows? SQL engines have optimized versions of certain common functions. You want to take advantage of those. Otherwise, you're leaving a bunch of performance on the table. And I haven't even talked about like date and time syntax or string concatenation rules or null behavior. Like, there is a lot of divergence here. You have the parameterization problem still. So like, templating can ease that if the parameters are straightforward, but they usually aren't for any like big problem you're doing. And like, eventually something's gonna end up conditioned on some other part of the parameter, or like some other thing that's happening in your query. It's just gonna get more and more complicated. And then there are outside factors that may impact what you're actually trying to build here, right? And these are some things you may have heard from people. And this query that started off so simple and straightforward is gonna grow and grow and grow until you end up with something maybe like this, right? So you're selecting the title of the movie, you're doing that initial cast, we've got that down. But now you like aren't sure. Maybe you're using like two different tables because you want to be running through different sets of ratings and movies. If you're changing the tables, you're probably changing the join keys, so you got to parameterize that. And substring matching definitely changes between engines, so you're going to need to have a special case for how to do the substring matching, which means you're parameterizing your parameters, which is a bad place to be. You probably don't remember, because no one does, when to use backticks or quotes to escape spaces, and is it single quotes or is it double quotes? And this is just terrible. It's terrible. No one wants to do this. And I'll say, of course, this is a caricature, but who here can say with full confidence that something like this would not happen at their workplace? For the video, there are no hands up in the room. Okay. So presented with something which is the worst code I've ever written in my life, ever, you might say, gross, I'm not going to use SQL. And that would be a very valid response here. But remember, it is everywhere. And a point that I overlooked a lot when I was really getting started with all this stuff is that computer scientists have been working on these problems for 50 years. And they have made some incredibly fast execution engines. And if you're not taking advantage of them, you're leaving just a preposterous amount of performance on the table. So where does that leave us? SQL standards are not standard. SQL can be a little convoluted. String generation is a bad idea, full stop. But we still want to write our analytics in Python. So what if, instead of generating strings, you write concise Python code that type checks and eventually generates strings? And that's Ibis. So Ibis is a lightweight Python library for data wrangling. It has a data frame API for Python. We have interfaces to, we like to say, dozens of query engines, one dozen, and a deferred execution model, which I'll talk about in a second. For any rstats people who have snuck in, welcome. And also, this is similar in spirit to dplyr or dbplyr. So deferred execution, what does that look like if we kind of go back to our local remote or local prod divide again? So you have Ibis on the left, you've got your remote engine on the right, and you connect to it. And you say, hey, I think you've got a table called ratings. And what you get back instead of all the data is just the schema, right? The column names and the types. And now, on your local, you can build up a query which is like going to be represented as an expression of the stuff you want to do. You can be validated on without knowing anything about the data other than the types and the names of the columns. And then we can compile it into SQL, send that SQL query over to the engine, have it execute that query, and then we get our results back. So a couple of nice things fall out of this. For the one thing, the machine on the left could be like a first-generation Raspberry Pi, and you're fine. Like, you don't need that machine to be fast, because that's not where the heavy lifting is happening. The machine on the right can be a beast, and then things just get faster. So your execution is going to happen at the speed of the back end, not of your local machine. And almost always, the thing on the right here is closer to the data and has a much bigger pipe to get it. So like, you're just going to avoid trying to, like, pull down many, many terabytes of data over your home internet connection. Another thing that can come out of this is that maybe you actually don't need to talk to the execution engine to get that first bit of information, right? Like, there could be some separate metadata store that's providing you with column names and data types. And then the only time you need to talk to the execution engine is when you're ready to execute something. So this can be, if there's contention around, like quotas on what you can run on that, or maybe it's expensive, or maybe something. But you can build up at least a preliminary workflow without ever talking to the execution engine until you're ready to go. And you'll know that at the very least, when it runs, it will run to completion. You may have the problem wrong, but like, it will run and it won't just fail out. And another thing that you can get out of this actually is just remove the top bit entirely. And if you are dealing with a set of table or a set of tables that have data appended to them all the time, but the schema doesn't change very often, you can just define the table on the Ibis side. Say, here are the column names, here are the types, build up your expression, compile it, ship it over, execute it, get it back. Right? So there's a couple of ways to do this. But how can we do this in a reliable way? Because otherwise this is worth nothing. And the answer is like some really strong typing and really good validation. So sort of a quick peek at what that looks like. We validate expressions at construction time, not at execution time. So if you have here a table ratings, it has 3 columns, they're all strings, and you try to say, check for where the number of votes is greater than 100. Well, because numVotes is currently a string, and string greater than 100 doesn't make a whole lot of sense, that's just going to come back and tell you, you can't do that. Those types aren't compatible for this kind of operation, right? And if you then cast it to an integer and then do the same thing, then you sort of get this representative expression that sort of letting you know, like, yeah, we will totally do that when you tell us to run it. And again, this doesn't mean that your query is correct, but it does mean that your query will execute, which is like a nice guarantee to have. So demo time. We'll see how this goes. All right. Is that big enough for everybody?
Yeah.
Great. Is it too big? No. All right. We're doing great then. Okay, so I'm going to import Ibis. I'm going to get into the correct environment. Great. I'm going to import Ibis. And I'm also going to import this underscore operator. I promise I'll tell you what that's about later, but for now, just pretend it's not there. And I'm going to connect to a local database file I have. I'm using duckdb here. I like duckdb, but it could be lots of things. So I've got a connection now. And now I'm just going to list the tables that are available in this database file I have. So I've got basics, ratings, movie lens. I'm going to pull out basics and ratings. So I can just say, give me the ratings table. I can say, give me the basics table. And now I have these sort of representations as alchemy tables. This is using SQLAlchemy to kind of do some of the translation. So you see there's some columns, there's some types, a lot of strings. And I could, for instance, just as a quick thing, I could execute this ratings table, and I'll limit it so it doesn't, just do too much right now. And this is basically saying select star from ratings and show me the first 10. And there's the first 10. Great. This comes back as a Pandas data frame by default, so now you're in Pandas land, you can do what you want. Or if you wanted to, say, take it out as a PyArrow table, you can do that too. Same thing, now it's PyArrow. You can get a PyArrow record batch reader if you want to iterate over a lot of stuff. Even if you're on an island, Ibis is a bird, it can fly, so you can talk to other stuff. For the purposes of a live demo, I'm going to turn interactive mode to true. What this means is every time that I hit enter, instead of showing you that deferred expression, we're going to execute basically the same thing I did, like a limit 10, just as much as we need to show you what's happening, so you're not just looking at a bunch of kind of abstract representation of the query. So now if I look at ratings, you get a nice table formatted with rich. Here's the same data, data types. If I look at basics, same deal. There's some data there. So let's start with the thing we're looking at. There's those ratings, there's the num votes, and there's the average rating. We want to make those the right types. So we could say ratings.select, and we want to say that the average rating should be equal to ratings.average rating, and we want to cast that to a float. Right, that was easy. And then let's say we also want to say that the num votes is equal to the number of votes, and that will cast to an int. And we'll use the right kind of quotes. Great, that was easy. And then we probably want that tconst value because that's the key we're going to join on later, so I'm going to stick it in there too. So here's our cleaned up table. This is just executing a couple of lines just to show you this, but it's easy to get the rest out. So I'm just going to save that into a variable named ratings because I'm going to overwrite it. And I'm just going to quickly define a little toggle function so I can toggle in and out of interactive mode easily, because otherwise this is going to get tricky. So this is what ratings looks like if it's not being executed. Right? You have the 3 columns of the table, and then we are selecting 3 columns, and 2 of those are casts so we get the right data type out. So that's sort of the representation of this thing. Let's go back into interactive mode. Look at basics. Basics has more columns than will fit in a zoomed in screen, so we can quickly see what the names are. tconst, that's that join key. Title type, primary type, original title, is adult, start year, end year, runtime minutes, genres. We will grab some of those. It's always good when you're looking at a data set to kind of just poke around though, right? So like, what do we have in title type? And a bunch of things. Let's say we want to only look at movies because we're building some kind of movie recommendation engine or something. So I see movie and I see TV movie, so we'll probably grab both of those out. Whenever you have something like is adult, like and it's supposed to be like a binary column, you might want to check that there are actually only 2 values in there, and there are, so that's great. We'll make this family friendly, so we'll filter out the adult films. And then let's see what's in genres, because it's always nice to know kind of what extra information we have. Junk, so we'll drop that, that's great to know. So let's get started cleaning this up, right? So first thing we might do is do a filter and say we want the title type to be one of movie or TV movie. Okay, it's pretty straightforward. And then let's say we want to also add that second filter, which is that the is adult field is equal to 0. And that broke. Because, remember, isAdult is defined as a string right now, and I said are equal to 0. You can't compare strings to integers. This didn't execute. Ibis stopped me before it built the expression. It said you're trying to compare 2 things that don't really talk to each other very well. So the easy thing to do here, and probably actually the more performant in this case, is just to compare it to a 0 string instead. And that works just fine. Right. And then what do we need to do? Well, we want to probably select out the columns that we now need. because we can drop some stuff that's no longer sort of important here. So we'll grab tconst because we want to join on that. We'll grab the primary title. I don't really care about the title type anymore. We've got our movies. We don't need the isAdult flag anymore because we've already filtered on that. And maybe I'll grab the, maybe I'll just grab those two actually, that's fine. All right, so there are our movies. And now we could save this into basics. And I'll toggle off interactive mode, and let's just take a quick look at what this looks like. And it is too big to see, but let me just jump up a bit. And so this is a little more, not complicated, just longer. There are more columns in the first place. But here's the original table. And then we're selecting some things. We have some predicates here. So does it contain movie and TV movie? Is the adult field equal to 0? And then we're just selecting out some columns at the end of that. So that's sort of what is in ratings. And so now we probably want to stick those two things together so we can actually use them. Right? So we want to say take basics and join that to ratings on the key tconst. And I'll turn interactive mode back on. Sweet, that's easy. Like there's our movies and there's our ratings, and we're good. Except we probably want to like show people specific movies, like maybe based on rating and how they're doing. So what we probably want to do then is order that by the, oh, here comes the underscore, the average rating. So the underscore in this case always refers to the previous expression, right? I just joined one table to another table. Saying average rating is now a little bit ambiguous if I'm saying basics.average rating or ratings.average rating, like where did it come from? It's a little bit hard to resolve that. So if you just want to say, look at the previous thing, please, and then use that column, this is a shortcut. You could do the same thing with a lambda function. This is just faster to type. So this is saying, join those and then order by average rating. And I haven't heard of any of these movies, but that's because I forgot how ratings work, and usually the higher number is better. So we will make this descending instead. Oop, I'm not going to do that yet. Thank you. Okay, and I still haven't heard of any of these movies because we probably don't want to treat a movie with a rating of 10 that has 8 votes the same as a movie with a rating of 10 that has 100,000 votes. So why don't we go ahead and filter out movies that have num votes greater than 1,000. So we want to make sure you have at least 1,000 votes to be included in our list here. I still haven't heard of any of these movies. So let's bump it up to 10,000. There's the Shawshank Redemption and the Godfather, so we're on the right track. I don't know what CM101 MMXI fundamentals is, so we're going to go a little higher up. Sorry if that's your favorite movie. No offense. And let's say 100,000. And that looks, I think that looks pretty much like the top 10 on IMDb. There might be some slight differences, but that seems like a reasonable, I've heard of these, I've seen a bunch of them. So that's, a little bit of like kind of just, checking our intuition here. So why don't we scroll that away in top films, because that is our list of top films. So we can look at top films, it'll execute. I'll toggle this off again, and we'll see that that top films representation, if we're not executing it in real time, is again, not that hard to really look through. I mean, it's the same tables we had, right? We had ratings, we had basics. Remember that on the basics, we were filtering on the title type and the taking out the adult stuff. Remember that in the ratings, we were doing the casts to make sure the data types match what we expect. And then we did a join. And then remember that after that join, we just wanted to make sure that the number of votes was greater than 100,000 and that the sort order should be the average rating in descending order. Right? So that's the whole thing. So one really cool thing about this, though, is that this is this abstract representation. Right? There's nothing about this that says run on duckdb. It just says run this on something that has columns that has these names and these data types. That's what we have here. So if I have a different connection, say to like a Postgres instance, I can execute the same thing and have a limit of 10, and I will get back, let me make that a little bigger now, because otherwise you really aren't going to believe me, are you? There's those movies, right? And if I wanted to say have a third connection to like a local SQLite database, then I can do the same thing, right? So long as the underlying database has those column names and those types, you can execute this. And you'll see that there are actually some slight differences in the results here, and that's because like I didn't like really constrain the query tightly enough to make sure that I'm getting back the same answers every time. I could also add like an order by on the number of votes, and I would get the same thing back, but you're subject to like slight sorting mismatches on, like, you know, if something's out of core, something's doing something in threads, you get slightly different answers. They're all correct based on the query I gave them. My query is underspecified. And then just to kind of prove that we can do this, I was saying, like, you know, what if you wanted to then have a bunch of queries that you were also then filtering on certain keywords? So you can do that. You can say, like, hey, for these pairs of keywords, yield me a filter on that table I pass in that is looking for the title having either this keyword or that keyword, right? And so I could say then, I could say something. Like, you know, get the queries from that top films. And let me turn interactive mode back on for this so we see something we can use. And just start going through them, right? I mean, I could first validate all these, but there's, you know, movies that have either laundry or samurai in them, and there's top films that have the word fight or whatever the other keyword was in there. So you can imagine that you could just have even like a generator or a list of queries that are just these abstract representations. And then you can, first off, if you get the list back in the first place, congratulations, all your queries are valid at least. And then just churn through them and execute them all. Cool. All right, so I'm going to stop live demo there, I think. We'll go back here. Let's recap what just happened. So I showed you we did some selects, some filters, some aggregations, some joins. Ibis lets you easily combine expressions, and you can target multiple backends, whether they're local or remote. For a live demo, they're all local because I'm not like relying on Snowflake being able to hit it on conference Wi-Fi. But again, you can run these anywhere that Ibis supports. Some other things I didn't show you, but that are worth mentioning. Sometimes you really need to write SQL, right? Maybe Ibis doesn't expose something, or you know how to spell this really specific operation in SQL, or someone you work with knows how to spell something specific in SQL, and you want to use it. We have an escape hatch called .sql that will let you write just string SQL, you know the query, and it will execute it and store that in the expression. This is actually still deferred. We do some cool stuff to make that happen. In this case, we're not saving you from the dialect differences. Like, you have to know the dialect you're writing to because we're passing this straight through the engine. So we're not kind of saving you from those little mismatches. But you can do this, it's an option. And one cool thing about this is that this doesn't mean you're stuck in SQL land now. You could then say, go back to Ibis land, chaining that. So this is like, I'm doing the cast on average rating in SQL, but then I can do the cast on num votes in Ibis. And then I can even alias that to a different name and then go back to SQL and select them out and rename them. And I mean, I don't recommend doing this, but you can, and you can ping pong back and forth. So if you're working with somebody, like a data engineer who really knows their stuff and has like, hey, here's how you get the view for this like crazy table you build everything off of, step one, .sql thing, and now you're in Python land and you can go from there. You're not like bound to stay in SQL just because that was your starting point. I've also been talking a lot about SQL, but it's not only SQL and Ibis. So we actually have other backends that are non-SQL backends, but you can use the same expressions to execute against them. So this, again, remember, this is just the simple example of the ratings and casting the stuff. Here's that expression for an alchemy table against duckdb. So you've seen this a couple times now, just the columns and then the selection rules. This is what it looks like if you want to execute against pandas. The only difference is at the top it says pandas table instead of alchemy table. If you want to execute against polars, the only difference is it says database table instead of pandas table or alchemy table, right? This thing's going to execute the same. And so where can you execute all this stuff? In lots of places. I'm going to read a lot of names now. ClickHouse, DAS, DataFusion, DuckDB, Impala, MySQL, Pandas, Polars, Postgres, PySpark, Snowflake, SQLite. We also have third-party backends for BigQuery and Heavy AI, which used to be called OmniSciDB. Snowflake and Polars are new in 4.0. And that is coming out in probably January, or you can try it out on the main branch right now. So I would propose that Ibis is a way for you to scale from dev to prod with less rewriting. I'm saying less rewriting because there are no golden tickets here. Like, floating point math exists, right? It isn't associative, so like any engine is going to do something slightly different, and you may get slightly different results. You just need to be aware of that, like when you're running these things. Like, you're going to get slightly different results if you have a bunch of chained mathematical operations. Just check your answers, right? Some things are inherently back-end specific. So, for instance, you can't use .sql on polars because polars doesn't speak SQL, I don't think. We can't pass it through to the underlying engine. And then there's some backend differences that either can't be or we just have not abstracted away, either because it's really hard or just intractable. So like it seems like every SQL engine has its own special regular expression dialect, and we do not yet have a magical library to translate between regular expression dialects. If somebody does, please talk to us. We will be very happy to incorporate it. But having said all of that, like I think it will definitely be less work than rewriting Pandas as a Spark data frame. Right? There's a little bit of extra work to do if you're moving around between backends, but like it should be pretty straightforward. So what's next for Ibis? We're going to add additional targets for query results, more options for query output formats. We've got PyArrow and Pandas right now. We're going to add a bunch more stuff. Work on our logical plan optimizations so that if you look at generated SQL, which I forgot to show you, I'll show you that in a second, you can kind of see what it looks like and it'll be much more concise. Some extra UX improvements, and seriously, like your request here, like we are interested in user feedback. Try it out, tell us what's great, tell us what you wish was different, what you want. We are on the internet all the time, and we will listen to you. Really quickly, I just didn't show you this. You can show SQL of a query, like ratings, and that's that query in PostgreSQL. Or if you wanted it in SQLite, you can do that too. So that's what's actually getting shipped over the wire when we send it to the engine. So if you ever need to examine it first to make sure it's doing something not insane, it's right there. And with that, I have got some time to take questions. And then just quickly, here's where you can find us on the internet, all those places. And a special note, my colleague Philip Cloud has a great YouTube channel called Philip in the Cloud. And every Monday is streaming like kind of live demos and or new features in Ibis. So if you want a quick way to see what's going on and also how to use it and some cool problems we're working on, check that out. And here are all of the ways to install it.
All right, thanks. So yeah, we have time for questions. How about you in the front?
For me, the killer feature that would make me actually try to start using this tomorrow would be if there was a way to take an existing SQL query and translate it into Ibis.
Totally.
How much is that pie in the sky?
So the question for recording is like, how pie in the sky is the idea of taking an existing SQL query and then translating it into Ibis Python? Automatically. So we are working on that. It's not pie in the sky. I mean, it sounds crazy, but we're close. So we can take existing SQL, parse it, and translate it into an Ibis expression already. And so the trick then is to go from the Ibis expression into a sort of quine that will give you the Python code that would have generated that Ibis expression, and it's that last bit that we're working on. But it's within reach, and once we have it, like, yeah, do you want to translate your entire existing SQL base into like Python code instead? Like, yes, you can do that soon. Not yet.
1 month, like 1 year?
I'm going to say under a year. Under a year. I'm gonna waffle a lot now. I think we could have it in a couple of months. We have a prototype that works for a bunch of stuff. We won't ship it until it's pretty reliable. But you could probably try it out soon. There's a PR open. Yes, you?
How do you think about performance optimizations? Obviously, one of the challenges of translating a SQL when you get to joins, you get to work on
Totally.
your optimization plan, hints. What do you do?
That is a great question. So the question is like, what do we do about our performance considerations and like how do we provide hints? And the answer is we don't worry about it very much. We definitely try to optimize the SQL we're generating to at least not have a whole bunch of extra projections and stuff. We are really relying on the back end. So like these queries, the data I'm using in the samples here are like not so huge that you see this, but like duckdb is going to be orders of magnitude faster than SQLite because duckdb has an amazing optimizer and Postgres has an amazing optimizer. So we're relying on the engines themselves to handle those optimizations. For things like hints, that's where .SQL comes in because it's always some wacky comment syntax that isn't part of the standard you have to fit in. Yes, you were there?
Have you planned doing this on object storage as well? Like in a database in Parquet in S3?
Totally. So the question is, can you do this for like Parquet files that are stored in S3? And the answer is yes. That we will have restrictions on backend because the backend needs to know how to ingest that thing. But for instance, for we just merged yesterday, do ibis.read and give it the S3 path to the Parquet file, and you'll get back an Ibis table that is linked to linked to DuckDB, and it will only pull down. It'll do push downs for you. So it'll only grab the columns you need to run your query. But yeah, you can register CSVs, TSVs, Parquet files, compressed CSV, compressed TSV. I'm missing some other stuff. Lots of stuff. Yeah. Yes.
Can you also do like mutation of your data, like updates, deletes?
Great question. Can you do mutation of the data, updates and deletes? Sometimes. That right now, that is something which is, I would say, not well unified among all the backends, kind of depending on when they were added, what was the main idea. We're working on, one of our other big pushes, aside from the Ibis coin thing, is to have a well-defined set of like APIs and rules around DDL stuff so that we can be consistent and predictable in the way that these things happen. So it's possible, but sometimes a little janky. Yeah.
A couple of questions. So, if you talk about the performance aspect,
Mhm.
is there a limitation on how much data IBIS can handle?
Is there a limitation on how much data Ibis can handle? The only limitation, because again, the execution is happening on the engine, right? So that might be on your laptop, or it might be, some huge monster like Snowflake instance or something. The limitation would be if you want to pull the results back and you want all of them, and you're going to get back an in-memory data frame if you ask for a Pandas data frame. If that is more RAM than your laptop has, then you're done. But you could still instead ask for that back as like an iterator of PyArrow batches or something, and then you could stream through them and do it. So the short answer is no, and the longer answer is sometimes. Yeah. Yeah, back there. Good.
So, is there a way for, let's say you have like a really complex kind of like Python function that can't be translated into SQL? Is there any concept of like UDFs and stuff that you can use with it?
Yeah, so the question is, what about UDFs? What about UDFs? We have UDF support for the Pandas and the Dask backends. That is the third big thing we're working on. How do you unify UDF behavior? Every SQL engine has like a different way to spell UDFs or a different language it wants them in. And we are working with several people who work on these engines to try to figure out what is a sane way to represent this information so that we can translate this and also have it still be performant. We could always like pickle something and send it over, but if you run that in like duckdb, I don't think it's going to be super fast. So, yeah, open question. Yeah.
So you were doing some pretty standard SQL stuff.
Yeah.
What about things like window functions, cubes? I mean, all the stuff you want to do in analytics.
Yeah, great question. So question like, what about the stuff that's harder than what I did in the live demo because I have to type live? So yes, we absolutely support window functions, like roll-ups. We've got, all that stuff is there. You can have, we support different ranges for the preceding and the, what's the opposite of preceding? Following windows. You can definitely do all of that. It's all available. We even sort of try to translate the window functions into Pandas stuff. That doesn't always work great, but for the SQL backends, it's definitely there. Yeah. Yes?
Is there any consideration around when you look at the actual SQL generated, you use T0, T1, not great names for humans who are reading it? Is there any consideration of using the variable names that were defined in the Python code for those?
Oh, that's a cool idea. Yeah, so I mean, we're dispatching for most of the SQL generation right now to SQLAlchemy. We also use sqlAlchemy, which is a really cool tool. Yeah, I mean, honestly, our general hope is that you don't have to look at the SQL, but I think that that's a good idea, and we could pull out some better names for it. Right now, though, it's what's being automatically generated, so we've got like an iterator and T, and it adds up. So yeah, that's definitely something we could work on. Sorry, the question was, can we make the alias names for the generated like tables and views better? Yes, over there.
Follow-up question on the performance part. So in IBIS, like we are generating the expression, and then the query is getting generated on the backend. So what's the difference, like we directly run the query and as compared to using IBIS, because we are adding something to make our compiler query, reader query, and then
Totally, yeah. So the question is like, what's the overhead of using Ibis since we're adding this compilation validation step in there before we then actually run that SQL against the engine? It'll depend on your laptop, but the answer is not a lot. I mean, it should also be, it's a constant time thing. It's about like 1.5 seconds to, I mean, and the other thing too is like, if you had a query that an expression that was made up of like thousands of transformations, it might start to lag a little bit, but I don't, like, it's unlikely I think you're gonna end up in that place. So it's usually constant time, and especially for any query of note, it's gonna be completely lost in the noise of the actual kind of time to perform like the big thing you're doing.
So if you say 1.5 seconds or whatever, like time frame, is it for some specified number of records? Have you side, or it's just
Oh, no, sorry, it's completely irrespective of the size of the data on the other side. It's just to take the expression that's in Python and compile it into a SQL string that we can ship across. So it has no impact, the data size has no impact on compilation time. Yeah. Yes.
So first of all, I think I'm a big fan of Ibis. Yeah, and I just have a request. I hope Ibis empowers some of the consistency work. For example, group by apply. Sorry, just group, just the group aggregation. The now handle, the join, now handle, and another thing is the sort. Like, now first, now last. All these things are like, if you want to like stick with the SQL standard, I think SQL in the SQL world, they are consistent.
Yes.
Pandas and DAS, they can have all different types of like different behaviors. I really hope you can like make this type of behaviors more consistent, so that people can switch to backend freely with the same behavior.
Okay, so the first thing he said was he's a big fan of Ibis. And then the second thing was a request to say, like, can Ibis sort of make consistent behavior of, like, the things that are not consistent right now, like null comparison behavior, how group bys behave, how order bys behave. I'll say that for the SQL side of the engines, we are doing what we can. It is currently hard to make some of those rules be respected in Pandas, although I think Pandas just added a thing which like lets you separate nans and nulls. So once that's more standard, we can start to approach consistency there. But so long as nans and nulls are basically the same thing, or there are enough like people using Pandas with that, we're not really able to overcome that because we actually need the semantic difference between those two ideas. Like one of those things is definitely a number sort of, and the other one isn't. So, yes.
So leading off of that a little bit,
Yeah.
so obviously you've got the SQL-like engines,
Yes.
execution engines, and then you have the other polars,
Mhm.
pandas,
Yes.
DAS. How are you thinking about keeping those consistent? They offer very different types of operations. Some of them are similar from an analytics perspective.
Mhm.
At the end of the day, translation is very different, and the way that you express those is very different. What represents an execution engine that is eligible to be included in here, and how do you think about consistencies across those?
Okay, so what's eligible to be included in IBIS as an execution engine, and how do we think about keeping consistency between how an IBIS expression then gets executed on that engine? Eligibility, I'm not gonna lie, like if someone opens a PR with their, like adding their backend, that's a great way to be eligible. Really great. We have
Is it consistent?
Yeah, it's,
Is there a minimum guarantee of consistency around features to make it into this platform?
we are, yeah, I mean, if someone came to us with an engine that only supported like select statements, I don't think we would let that pass. I wouldn't say there's like a strict governance, document around that just yet. We have a table on the website, which is really, really long and sometimes hard to look at, which will show you, for instance, like we have support for geospatial operations that only works in Postgres and maybe MySQL or something. But you can see like where the gaps are between them because yeah, some engines can do things that other engines can't. If it's in there, our general feeling is like certainly for what I would think of as being like encompassed by like, I don't have a good word for this, normal standard SQL, like don't do crazy stuff, that is uniform across all of them. There are definitely spots where if you get onto the edges and the fringes, like things will, like, and what happens is IBIS will just tell you that operation is not implemented for this backend. So again, we'll at least tell you we can't do it before you try to run it on the thing. And we're always like looking to expand those things. If it's just linked to the appropriate like compute node thing in whatever engine, we'll add that in, no problem. If it's some fundamental difference about what an operation means, or it just isn't present on the actual execution engine, then we're not yet going in and adding those to the execution engine so that it matches up. So.
Great. So it is 12:30, time for lunch. If anyone else has questions, you're welcome to ask Gil. But otherwise, lunchtime.